Okay, so I think I'm gonna start now. So good afternoon, everybody. So last time I explained this program here, flashing LED, and I used assembly in this program. So the main things we did here, as I told you, we have two main for every board. We have two main registers. We are going to use them all the time. Number one, data direction register, DDR, and then you put here the one letter for the port. So you have DTRA, we have DTRH, B, and so on for every port. And I told you about this one. You have to use it only one time to program the port input or output. It depends on the device you are connected. That means for port B, because it's output, you are gonna program it output because LEDs are connected to port B. For port A is connected here. Okay, so you have to program it input, not output. Okay, this programming should be done one time as we did here. Okay, guys. Also, I explained the other important register, which is here in this table. Yeah, so here in this table, like for register A, you have to use port A, register B, E. For H, you should not use port H. You have to use it PTH this way, okay? Again, the reason we are doing it this way because all these registers are like memory locations. So you have to write address, okay? However, we don't like to remember too many numbers and use too many numbers. We like to use English words. That's why they are defined in this file here using equate, as I explained last time. So all what you have to do, just use the English word. So this is the second register I told you about, and very simple. This is like a register. It has address. That is why I told you any instruction I taught in chapter 2 for memory locations, still you can use them with these registers, and also DDRA. Everything I taught, and I told you this is for a memory location, you can use it with these two registers. Okay. So one more thing for this register here, it's just this is a byte, as you see here. All what you have to do, if this is an input, all what you have to do, you have to check. For example, I want to check this bit. Is this 0 or 1? And that's very easy. That's what we have done before. That's because if this is an input port, so this pin is connected to the pin. And if this pin has 5 volts, this one automatically should be 1, right? We didn't do that yet, but we are going to do it when I teach the switches here, okay, later. But what I did the opposite. The opposite, it was like an output port. In case of output port, you have a byte, and this is the address of the byte. So you can use one of these. For example, if it is port B, you can use this one. If A, you can use this one, and so on. So if you have a byte, if you write here in this bit 1, so actually the pin should be 5 volts, because I told you every port should have pins, external pins. Also, it should have 2 registers, as I explained. So I explained this program here, and programming wise, nothing new. I just used what I taught in chapter 2 here. Okay, so I told you this part is just for registration. Okay, and this is in order to pull the pin high. So all what you have to do, port B is just a byte. So I have to pull this bit high. Once you write 1 in this bit, the pin, the corresponding pin PB0 on the board should be 5 volts, and this pin is connected to the one LED, because I told you we have in here 8 LEDs, as you see here. These LEDs are connected to port B, right? Also, the 7 segment, when the time comes, I explain the 7 segments, they also connected to port B. Okay, so here, and then I explain the idea. How can you wait for 1 second, and then how can you pull it low? How can you wait 1 second and just repeat? Now, I'm going to explain the same program, but in C language. In C language. So let's see how can you do that. Okay. As you will see right now, nothing is new. It's exactly the same thing I did here. I'm going to do it in C language. The only difference is instead of using assembly instructions, I'm going to use C instructions. That's what I want to say. For example, if I want to move, I want to do something like move, for example, here. If I want to do something like that, move DGRB FF. How I can do that in C language? Okay. So the way you have to do it, guys, you can do DDRP, like it's like a variable. Just use it the name. Okay. This is equal to FF and semicolons. Exactly the same thing. However, how the C language can know if this number is hexadecimal or binary, or this number is decimal? Okay, same thing like assembly, but we are going to use different prefix. Okay, so in assembly we used percent if you mean this is binary, but here we are going to use 0, I think 0B. Let me check. I'm going to teach it now. Yeah. Look here. So here, if you put here a prefix 0x, so that means it is hexadecimal. Again, nothing new. This is similar to what I taught in assembly, but just I use different format. Okay, so instead of using $sign in assembly, we're going to use 0x, right? Also, instead of using percent in assembly, here we are going to use 0b, as you see here. Is that okay? Also, if you put nothing here, this is similar to this is decimal. This is similar to what we did in assembly as well. Is that okay? Very easy. So number one, guys, I'm just explaining. I want to tell you, I'm not going to teach anything new. Everything I did here, I'm going to do it also in assembly, but I'm going to use, in C, but I'm going to use the C instructions. So the way I have to do this one, it has to be 0x here. Okay, and that's it. So this is one thing. So instead of using move, and again, you don't need to define all these registers. You don't need to define them because you already defined in this file, and you are going to include this file anyway, as you will see right now. I'm talking about C. So yeah, so you are going to include the same file here in C, so you don't need to define. You know, in C language, before you are using any variable, you have to define it, as you know, right? But for this one, for these registers, you don't need, okay, because you already defined here. Just use them. Okay. So this is one thing. This is how can you do. Yeah. This is how can you do move. Okay. How can you write to a register? The second thing is how can now I need bit set. Also, I need bit clear. Okay. So if you have port B, how can you clear 1 bit? How can you set 1 bit? Is that okay? In C language. Okay. So for sure, in C language, we don't have bit set and we don't have bit clear. Okay. So how can we do it? Similar to what I taught in chapter 2, if you remember, I told you if you wanna set some bits, you have to use OR, logic OR. Do you remember how we made it? The way we made it is, for example, if I wanna set this bit, so I have to OR it with 1. The bits you don't want to change, you have to put zeros here. And then you do bit by bit AND operation. That's exactly what I'm gonna do right now in C language, okay? So for example, if I wanna do something like this one in C language, how I can do it? Okay, so the way I'm gonna do it, I'm gonna say port B is equal to port B, is that okay? Or, this means or. This symbol means or in C language, okay? Or 0B, instead of dollars, instead of percent, I'm going to use 0B. Then I'm going to say 000000001, semicolon. Very easy, right? This is how can you set some bits using or. Again, nothing is new. This is exactly what I taught in chapter 2. The only difference is this symbol here. It means bit by bit logic or. Okay. Same thing now. How I do this delay? As you will see right now, we have a function. You can just use the function to do the delay. Okay. Also, how I can clear some bits, bit clear. Do we have bit clear in C? No, we don't have a similar instruction in C. But again, similar to what I taught in chapter 2, similar to what I taught in chapter 2. If you want to clear some bits, all what you have to do, you have to use logic AND, as I explained, and the way you have to do it. For example, if I want to clear this bit, okay, so you have to put here 0, and then the bits you don't want to change, you have to put once, and then you do a logic AND. Is that okay? That's what we did in I explained in chapter 2. Okay, so now same thing, I'm gonna do it right now. So if I want to do same thing like this one in C, the way I'm gonna do it, I'm gonna say port B is equal to port P, okay, and this is logic AND. This one means logic AND, bit by bit AND, okay, and 0B of 11111110. That's it, and semicolon. You know, in C language we have to end every instruction with semicolon. Okay, guys. So that's what I'm going to explain right now. I'm going to repeat the same program here, as you will see right now, and we can do it same way like this one. Okay, as I explained here or here, you can do the same way like this one, or you can use functions. So I'm going to also explain some functions. You can whatever you like. So I'm going to explain different ways. If you want to do this way like assembly, it's totally fine. If you want to use functions, I'm going to teach you some functions you can just use. Is that okay? So, okay. So now I wanna explain some operators, as you see here, some operators in C language. Maybe you didn't see before, you didn't use before. I told you this operator means logic AND, bit by bit, logic AND, okay? As I did right now. This one means logic OR. This one here means XOR, XOR. This one here means NOT, or one's complement. This one here means shift right. This one here means shift left. Is that okay? And as you will see right now, in C language, in assembly, to shift right or shift left, every instruction is going to shift only one time. So if I want to shift 2 times, I have to write the instruction 2 times, right? Here it's not like that. Here you can write how many shifts you need. For example, look at this one here. Look, for example, look what I did here, guys. When I say port B is equal to port B shifted 4 times, okay? This is little bit difference between C and the assembly, right? So I don't, so here, the number you put here, this is the number of shifts. And look at the direction here. So the direction of this, it's like an arrow, okay? So this is shift left. So here you want to shift left 4 times, okay? And the result is going to be stored in port B, okay? One more thing also, you know from C language, when you have something like that in C language, when you have, for example, I is equal to I plus 2, okay? If you have something like that in C language, you can write it, you can write like I plus equal to, you are, okay? That, again, both of them are okay, but this is just short format, okay? So if you use this one, it's totally fine. If you use this one, it's totally fine, okay? Just short format. Same thing here, same thing here. So here, what I did here, similar to what I did here, just short format. So I can do, you used to do it with the arithmetic instruction, but still also I can do it with this one, okay? So now, let's see how can you clear bit 0. That's exactly what I explained right now. You can say port B is equal to port B and FE. Again, if you don't want to write it in hexadecimal, that's totally fine. You can say, instead of this one, you can say 0B, and then you say 1111110. It's whatever you like. This one is okay, this one is okay, okay? Also, if you want to write it this way or this way, same thing. Just this one is compact format. Is that okay? Same thing here for C language. That's what I taught right now. It's exactly same thing. You can write it in hexadecimal or you can write it in binary. Okay, so this is how can you clear some bits, and this is how can you set some bits in C language. Again, nothing is new. I already taught in chapter 2 how can you use logic operation to clear and set some bits. The only new thing here is just the format. This like this, I use here the format of C language. If you wanna flip the first bit, flip, toggle, right? As I explained in chapter 2, in order to toggle some bits, you have to use XOR. and this is XOR is here. XOR is here. So if you look at this one here, this is 0, 0, 0, 0, 0, 0, 1. So you actually toggle the least significant bit. You toggle the first significant. Let's look at this one here, guys. When I say PTH, PTH, it's a byte for port H. So I'm going to read the byte at port H. Remember, as I'm going to explain later, port H is the switches here are connected to port H. Okay. So here I'm going to read port H, and then I'm going to complement this value, flip complement, because this sign here means you complement. So if this one, for example, if this one is 1, 1, 1, 1, 1, 1, 1, the result is going to be 0, 0, 0, because you flip the bits. Once complement. This one means once complement. And then the result, I'm going to store it in port B. So this instruction, you are not going to change port H. I'm going to read the value at port H. I'm going to complement it, and then I'm going to send it to port B. Okay, guys. And here, same thing here for shift. I can shift. This is shift right. Look at the direction here. Shift right. This one shift left. Okay. I want to tell you something here. I don't want to be confused. Maybe you are familiar with this one because I also used this one in chapter 2. Okay. Also, you may be familiar with this one, but there is big difference, very big difference between this one and between this one. Big difference. What is the difference between them? This one is AND, logic AND, bit by bit, logic AND, right? But this one, as I explained in chapter 2, this one, if you have two conditions, for example, I can say if A is greater than 2 and B is less than 5. So here, this one, this is AND, but for condition. It's not by bit by bit AND. It's not logic AND. Okay. Same thing for this one here. Okay. So if it is only one, this means a bit by bit logic OR. But if it is two of them, so this one is used with condition. It's OR, but OR for conditions. It's not like bit by bit. Anyway, so also for condition, so we call it like relational operators. You know this one is equal. You know this one is not equal. Greater, greater or equal, less, less or equal. This one is not, as you know. So here, maybe I don't want to spend too much time on this one here. You should be familiar. I already explained something in chapter. You should be familiar with C language. So for example, if I say if A1 is equal to A2, execute this statement, right? So this is a condition. Same thing, if A1 is equal to A2, execute this one. However, if it is only one line, you don't need to use braces. But you know, if it is more than one line, you have to use braces. You can use braces all the time. That's totally fine. You can use braces all the time, but it's not required if it's only one line, right? So this condition here, if A1 does not equal A2, this one, if A1 greater than A2, greater, this is a condition. I think that's easy. Yeah, that's what I explained. Two condition here. Okay. One more thing I want to tell you guys is you should know for sure C language, especially we're not going to use, we need the basics of C language. We're not going to go like classes or object oriented, or we're not going to go that far, at least the basics of C language. But maybe because of you, maybe forgot, maybe they took the C language some long time ago. In the course website, I put this review for C language. Okay, I don't have time to explain everything, but I'm going to go through it quickly. But you should understand it. If you don't, you should read it. You should understand it. Nothing is here is new. This is exactly similar to what you had before. So you know, in C language, you should have at least one function. We call it the main function. Okay, this is one thing. The other thing, you know, if you define the variable here inside the main function, so this variable we call it local variables because you can only use inside this function. This function can be main or any other function. Any variable you define it inside the function, it only can be used inside this function. Okay. However, if you define outside here, that means this we call it global. What global means? Everybody can access or can use this variable. What do you mean by everybody? I mean all the functions, because usually you are going to have more than one function, okay? But at least you should have one, the mean. But usually you have mean and you have many other functions, okay? So if you have a variable here like a is here, right? You cannot use it in other function. You cannot. But if I put it outside here, sorry, a is global. I made a mistake. So for example, here m and n, these are local. So m and n, you cannot use them in other functions, but these ones here are global, so you can access them anywhere. Okay. Here I'm explaining how can you make a function, how can you call a function, how can you return a value from a function using return instruction, as you see here. Again, also here data types, so integer, character. We have another data type, maybe you didn't use it before, like bytes. Okay, this one is used to define a byte variable, one byte. Okay. So here I explain here, for example, integer I, integer j. So these variables are uninitialized. Some variables here are initialized, as you see here, right? Byte. So byte is like integer, but it's only for one byte. Okay. And again, you can put your numbers decimal. You can put it in hexadecimal. You can put it in binary. Okay. What else I have? Yeah, here I'm telling you the size of each one. So if it is integer, it's going to be 2 bytes. Short is going to be 2 bytes. Some of them are unsigned, like you have unsigned integer, 2 bytes. It can go from 0 to 65. I think you can understand it well now after what I taught in assembly. So you can understand it now, because this one is 16 bits. 16 bits can go from 0 until 65, 535. Here, same thing. This integer is unsigned. So it can go from this value to this value, sign. We have float, anyway. We have also the idea of truncation. Truncation happens when you have different types in one equation. For example, here you have you divide integer by double, and you want to store the result in a double. So you want to do something like that, okay? But here, this one is integer, this one is double, and you want to store the result in double. So there is something we call it automatic truncation. Automatic means automatically, when the calculation is done, usually the small size is going to be stored in a bigger size. That means this integer is going to be stored in double. Okay, because double is bigger than integer. Anyway, this is automatically done. And then you are going to divide integer double by double, store the result in a double. Okay. I give you some examples here. You can force this truncation by doing something like that here. Okay, so that means sum is integer. So here you are forcing it. So please, when you do this still sum is integer. I just want you to understand, still sum is integer. I'm not going to change the type of sum. I'm gonna just in the calculation. So here, when you take the number of sum, just you have to convert it, or you have to put it like in a bigger space and divide it and so on. Okay, anyway. Here I explain how can you define arrays. Okay, some arrays are uninitialized, some are, this one is uninitialized, this one is initialized. Here also I'm explaining how can you read or write arrays. You know, these brackets is square brackets here, and so for example, if I say buffer of 0, that means the element number 0, or buffer of 1, element number 1, element number 2, and so on. Okay. These are the operators I explained. Okay. Okay. These are the operators. This is how can you make if statement. I don't think I have to spend time on this one. Yeah. This is what I told you when I say y should equal x plus plus. You remember I explained also this one in chapter 2. When you put plus here is prefix or postfix. The concept here is similar to what I explained in addressing modes in assembly. Okay, so this here actually are gonna do two operations. Y is equal to x, and also x is equal x plus 1. But if you put this is post, because it's post, you are gonna assign x to y first and then increment x. But if you put x here, I'm gonna do the same thing, but this operation will be done first. Anyway, let me see more. Yeah, so here you are familiar with this arithmetic operation like plus, like minus, okay, multiplication, division, and also percent. This percent, maybe I want to spend some time here because we're going to use it later. Percent. So what is the difference between a percent here? This percent is going to give you the remainder. You remember in C language, I got a quotient and I got a remainder. Okay. So how can you do the same thing in C? Because we're going to need it later. For example, if I say integer K should equal A divided by B. Okay. When I say, for example, integer F should make it Q, for example, Q and R should equal A percent B. Okay. So what is the difference between them? Here you actually, because it's integer. So here, if the result, here you are storing the quotient because it's integer. So if the result, it's not float. If it's float, for example, if it's 3.333, so you can store it this way, okay? However, because it's integer, you are gonna store the quotient. So that means if it is 3.7, 3.9, so you are gonna get only 3, okay? So if you wanna do like assembly, because we will do it later in this course, how can you get, when you do division, how can you get the quotient and the remainder separately? This is the way you have to do it. If I use this one, I'm gonna get the quotient, provided that you store the result in integer. But if you use percent, you are gonna get the remainder here. Is that okay? Again, this is assignment operators, nothing is new. This is how can you do if statement, if else statement. I think I already taught it in chapter 2 as well. Nested if, it means if inside if. I give you some examples here to understand it. Also for, while, do, while. I think I already explained all of this, and maybe I shouldn't spend more time here. Also, I give you some examples on using arrays. For example, here, if you have array here. So here in the first iteration, I is equal to 0. So when you say n of 0, because this one will be 0, it means this is the first element in n, because n is like an array, right? So 0 means this element. N of 1 means this element here, n of 1. If you are talking about this element, so n of 2, and so on. Okay. Anyway, this is if it is one-dimension array. I also give you an example for for two-dimension arrays. While I already explained it, and also while one, if you remember this, how can you make infinite loops? Do while. Okay. If you go back to chapter 2, I already explained them, so we need them here. Switch case. Anyway, so I explained it as well. I give you example here, and this is you again. C language is a prerequisite. Okay, I'm making a quick review, but you should, if you need any help, let us know. Also, if you search online, especially, I'm not asking for like advanced C language, just the basics of C language. So if you have, I know maybe some of you have problems here, that's totally fine, no problem at all. We are here to help you, but just read this one. If you search online, you will find it's a prerequisite, you should know it anyway, okay? So now, I'm gonna explain how can you do the same thing I explained to before, but using C language instead of using assembly. So the way I'm gonna teach, see here, guys. First of all, you have to include. This is similar. This is a program written in C, and as I told you guys, all the programs in chapter 3, 4, 5. All the programs you have all the programs on the course website. You can download them. I'm quite sure they are working. You can run them. You have the board, and this is the name of the program, Flashing C. Okay, so you will find it in the course website. So now this is a C program. Number one, you have to write this include for sure. This is the same file we used to include in C language. In assembly. But I just use the format of C language, include. So this is the same thing like what used in. Also, you have to use these two instructions. Okay, especially this instruction, you have to tell the code warrior which processor exactly you are gonna use. So this is the number of our processors. That's why I have, because as you know, this is the same thing. When you create a new project in assembly, you have to select this number, right? because this is the number for our microcontroller, because the code warrior is not only for this microcontroller. It's a family. So we have several numbers of the microcontroller, so you can use the same program for all of them. So all what you have to do, you have to tell the assembler what's the number, okay? And this is the number of our, if you see, it's written here, it's written in the chip. This is the number of our micro. So I have to tell the the C language, right? I have to tell the C language what's the type of your processor. Anyway, so always we have to write this part in C language, and then similar to what I told you guys, in C language you should have at least one main function. That's what I'm doing here. Also, in all the programs, we are gonna call a function. This function is called PLL initialization. So this function we're gonna call it all the time, and this function we're gonna call it all the time just to set up the system. It's like initialization to 24 megahertz. I want to tell you, by the way, this is the operating frequency. You can program it, so you can make it less but not more, because it's a maximum. Okay, so you can program it. So, and then if you are very interested, how can you do it? We're not going to do it here in this course, but I think that in one chapter in the textbook, it's explaining how can you change the operating frequency. You have to write some instructions. Anyway, this is out of the scope. So just you can use this one to do initialization. If you want to understand it more, I'm going to tell you what you have to do. Just give me 1 minute. Okay. Now, as I told you, I want to do the same thing as I did here in the assembly. Exactly the same thing as we did here. So all what you have to do, guys, is, for example, for us, DGRB 0xFF. Okay. So here, this one, here, you program port B as output. Is that okay? Yeah, you don't need to define the direction registers. You don't need to define them because they already defined here. Okay, you can just use them. So now this is exactly like move. When you used to move instruction, move byte, right? FF. Okay, you move FF to DGRP, data direction. It's exactly the same thing. So I can do this way for data for register B. Also, I can program here. I can program also. I have, as I explained last time, we're going to use register B completely. Actually, here I programmed. You are going to use register B, register J, register P. Okay, as I did before, and that's what I did here. So I programmed all of them are output. One more thing I told you last time, if you remember, what I told you last time here, it's. Here, for example, I'm not going to use the whole port J. What I did here, I programmed the whole port, but I'm not going to use all of it. I just need BG1, if you remember, BG1. It's okay here to do that. Why? Because I'm not going to use the other pins on port J. So if you program everything, it's not going to hurt. Okay. But if you want to be more specific, I don't know. I'm not gonna program the whole port. I want to just program BG1. Instead of using this one, you have to set BG1. And how can you set? Using OR. So the way, instead of writing this one, you can say DDRJ should equal DDRJ or, okay, then 0B. Then you have to say 00000. 010, right? Yeah, this way. So you can write this way, okay, instead of programming everything. Again, I think later in this course, this may make some trouble for us. Is when you use, I'm going to tell you how. We have port P. Port P, the first 4 bits are used to enable or disable 7 segment. However, the next 3 bits are used for RGB. Okay, RGB LED. As I'm going to explain later, we have one LED. I can jump quickly to this one. We have one, yeah. We have here this one, this LED. You can turn it one of the 3 colors. So that's why you have here BB4, BB5, BB6. Okay. So if you put here 1, you turn the red on. So it's one LED, but it can give you one of three colors, red, green, or blue. That's why it's called RGB. R for red, green, blue. So they are connected to PB. So now you may have trouble if you just write. And I think this will be a problem in one of the labs. So port P, if you just write, because now I'm going to use the whole port. If you just write something to port P, so this is not gonna only impact 7 segment, but also it's gonna impact RGB because you are gonna use the RGB at this time. So anyway, you have to be smart here. You have to be careful. If one port, I'm gonna use all of them in different way. So you have, again, the conclusion. What I want to say is, you have the option either you write everything to the board, or you can just change specific bits. Okay. Anyway, for some reason, just to make it easy here, I just decided to change everything. So here, again, nothing here is new. This is exactly similar to what I did in assembly, but here I'm using the C language format. So what I'm doing here is, as you see here, I'm programming port B as output. I'm programming port J as output. I'm programming port P as output. And then here, I put 0 in BG1. I actually put to everything, just I put 0 in everything. But actually, I'm just interested here in BG1 in order to enable LEDs. Is that okay? And then here, I'm going to put FF in BTP. Actually, I'm also interested only in the first 4 bits, but I'm going to put once everywhere. Okay, it's not going to hurt me because I'm not using the RGB here. Okay, anyway, so this is similar to what we did in C language. Similar to what we did in assembly. You have to do initialization at the beginning of your program. And then if you see here, guys, I'm going to do like infinite loop. So I'm going to loop here all the time. And similar to what I did in assembly, number 1, you have to turn the LED on. You have to wait 1 second, turn it off, wait 1 second, repeat. That's exactly what I did here. So number 1, how can you turn it on? How can I turn one LED on? Again, as I told you before, one way to do it, guys, you can do using this idea. This is exactly what I did in assembly. Port B should equal port B, and then this one here, because I put in number 2. So here you are gonna turn this bit number 1. You start from 0 to 7. So you are gonna turn the second, not the first. Okay. If you need to turn the first on, you can just put here 1. Okay. But anyway, so here, you can use it this way if you want. This is exactly what I did in assembly, but here I use the format of C language. Or you have a function. You can use just a function. Okay. So you can say, for example, you can say you have this function LED on. So this function is used if you want to turn one LED on, and you have to give me here a number. This number can be 0, 1, 2, 3 until 7. This is which you have to tell me which LED you want to turn on. Is that okay? So if you give me 0, so I'm gonna turn LED 0 on, then or 1 or 2 or 3. Okay. So this one can turn only one LED at a time. Okay. So just tell me. So here I put 1 because I want to turn LED 1 on. Then I have another function. It's called MS delay. This is in C. In assembly, where this function is called delay YMS. Do you remember? It's exactly the same thing. This is the equivalent function in assembly in C. So here, here I'm gonna put 1000. This is exactly similar to what I did in assembly, because here I'm making a delay for 1000 millisecond, which is 1 second. So this one is gonna turn LED number 1 on. Then I'm gonna wait 1 second. Then I'm gonna turn LED number 1 off. I'm gonna wait 1 second and then repeat. Any questions? So you can, if you want to do this way, I'm totally fine. If you want to use function, it's also totally fine. Okay, guys. One more thing. Also, the initialization. If you want to do the initialization this way, it's totally fine. Or also we have 2 functions here. One is called LED enable, and one is called 7 segment disable. Right? So if you go inside this function, the LED enable, you will see this one and also this one these two are already there. Okay, but if you go to the and this one, sorry, yeah, this one as well. Okay, but if you go to the 7 segment disable, you find these two here. Is that okay? So same thing here, guys. So same thing. If you want to use this one, it's okay. If you want to use function, it's okay. However, this is the most important thing. However, look here what I want to say. C language is high-level programming language, high level. Okay, that means you should be able to program the microcontroller even if you don't know the very basics of the hardware. I don't know if we have ports or not. I don't know that I have to program ports input or output. I don't know if the LEDs are connected to port B or A or X or whatever. I don't know. You get what I'm saying? It's very high level. So how can we achieve that? We achieve that using functions. So I'm going to tell you, don't worry about the hardware at all. If you want to turn the LED on, just use this function. We'll do it. How? Don't worry about it. Because I want to hide the details from you, right? Again, because high-level programming language, same thing. So what I'm saying, if you want to use this way, I'm totally fine. If you want to use this way, I'm totally fine. But just you should understand, this way is like high-level style, high-level programming style. So this is like high-level programming style. I want to hide the details from you. You don't even need to know, you have to program ports. You don't even to know that there are ports at all, okay? This is, it's more like low-level. Yeah, you are writing it in C language. Sorry, yes, you are writing it in C language, but the style, these details are like low-level, okay? Anyway, so what I'm saying, guys, I don't want to confuse you. I'm gonna, you know, I have to explain things in different ways, and then whatever you like. So if you want to use function, I'm totally fine. Here, I'm totally fine, and so on, okay? Let's see also. So here we have this function, guys, ms_delay, and you can put here the number in millisecond. We have another one, us_delay here. This is in microsecond. We have LED on, and you have to give me which number. You have to give me a number from 0 to 7. You have to tell me which one you want to turn on. Same thing, LED off here, as you see here, LED off. So this one to turn on, this one is to turn off. So here, turn the LED number 0 on, turn the LED number 0 off, okay, and so on. Also, we have LED enable, and we have 7 segment disable functions here, okay? Because I'm gonna repeat it. Last time I told you, we have port B. Port B, we have connected to 4 7 segment. So this is 4 7 segment, as you see them here, 4 7 segment. Also, they are connected to LEDs. Okay, so whatever you write on port B should be shown on all of them if all of them are enabled. Again, they did it this way because this one is used for education. You want to put too many things, but when you do your project, you don't need to do this way. Okay, you don't need to design it this way. But that is why here they put PG1 as enabled. Here they put PB0, PB1, PB2, PB3. And usually only one of them should be on at a time. So if I want to use the LEDs, so I have to put here 0, and then I have to put here once, right? To make sure this is the only one is gonna work. If all of them is gonna work, it doesn't make sense. You will see just a random shapes here. It doesn't make any sense. Anyway, also, if I want to use this one as I'm gonna teach you later, you can put here 0. You have to put once everywhere to turn all of them off except only one. Okay. So that's why you have LED enable, we have 7 segment disable. As you will see later, when I use the 7 segment, I should enable the 7 segment and I should disable the LEDs, as you will see later. Okay. Now, I want to tell you something important about C language. You are telling us we have a number of functions we are going to use all the time in C language. Is that okay? So you remember, I did the same thing in assembly. Just to quickly go back. In assembly, I told you we have a subroutine, I put, this is just one function here, delay YMS. I told you I'm going to teach you more functions in the future, just to make programming easier. Instead of you copy paste in your program, copy from the slide, put it in your program. I made it easy. I told you I created a file. This file is in the course website. Okay, you have to include it in your program. Just make programming easy. If you go and open this file. When you open it, you will find all the subroutines are there. Okay, you can just include it and just use it. Is that okay? Because I told you, these functions are not coming with these functions are not coming with the code warrior, right? So that's why you have to include this file. Okay. Now let's come to the C language. It looks like you did the same thing in C language. Yes, in C language we have also a number of subroutines, number of functions, as you see here. I'm going to teach you more functions in the future for sure. So now the question is, are these functions coming with code warrior? The answer is no. Okay, the answer is no. These functions are not coming with code warrior. Okay, so how I use them? That means if I create a new project and use this function, code warrior is going to give me error for sure. Code warrior is going to tell you, I don't understand what you didn't define this function. This function does not exist. You have to define it. Can you say? So what can we do? Here I give you a tutorial about what you have to do, guys. Let me see here. Okay, so the way I made it is, and this is very important. The way I made it, I created a project in C language, and I defined all the functions we are gonna use in this project. Is that okay? And more interestingly, all these functions are written in assembly, as you will see right now. So I created too many functions are written in assembly, and then I'm gonna call them from the C language and use them in the C language. Is that okay? So all these functions are defined in a project. Okay, this project I posted this project in the course website. This one here. Okay, so all what you have to do, you have to download this project. You have to unzip it. This is the project. You will find it in the course website. And then you have to, this is a project after you unzip the project, and then you have to open it or you have to run it. Once you open it, you will find something like that. This is a project. You find it something like that, guys. If you look, I'm going to show you right now, inside this project, you will see all the functions I'm going to teach in C language are defined here, and they are written in assembly. Is that okay? So two things here I want to teach. Number one, and this is a very important thing, two things I want to teach. Number one, very important. In assembly, how I can run assembly program? Why you ask this question? In the last 6 weeks, okay, what we did, you created a new project, right? And then you wrote your program and you run it, right? That's what we did before. Same thing you will do right here. But the only difference is you have to include the file that has subroutines. So same thing, when you run assembly, you have to create a new project in assembly. But all what you have to do, just include, and you have tutorial in the course website, how can you include the subroutine and just use it, okay? This is one thing. Number two, for C language, should I do the same thing in C language? The answer is no. In C language, you should not create a new project. Because if you create a new project, it's going to tell you, I don't know these functions because this project doesn't have the functions. All what you have to do is, all the time you have to open this project. And as you will see right now, all the functions are defined here, as you will see. All what you have to do, just to modify this, you have some initial program, as you see here. All what you have to do, just remove this program and then put your program is here. So let me say it again. All the time in C language, you should not create a new project. Just open this project, right? And then go to main.c. Can you see here main.c? Because this is where your program should be, main.c, okay? Main.c, you will find something here, just replace it, and you have to use this project. Why this project? Because all the functions are defined here. This is one thing. Now you should understand how can you run C program. Don't create a new project. If you create a new project, is going to tell you I'm not familiar with these functions, okay? So second thing now, you are telling us you created a project in C language, and then you defined some function in assembly and used them in C. Yes, I did, okay? So I'm gonna, here in this tutorial, I show you how I made it. However, for the purpose of this course, I don't think you are gonna need it, okay? But just if you wanna learn, I'm not gonna ask you to write a new function in C and call it an assembly. But for sure, if you wanna learn more, you can see here how I made this function. So, okay, so here I'm giving you a tutorial. I wanna create a new function. This new function is called the display LEDs, which accept 3 arguments. As you see here, byte, byte, byte. It compares the 3 arguments and displays the bigger value on the LEDs. Is that okay? So here I'm gonna send 3 numbers, and then it's gonna take the bigger number as displayed on the LED. So I wanna create this function I'm gonna use this function in C, and these functions will be written in assembly. Again, I'm not asking you to do that. For example, if you go here main.asm, you will find all the function definitions are here. So all the functions are defined here. So what I did, I just added this new function. Also here in main.asm.h, you will see also a definition is here. So this is all the function I'm gonna teach. Okay, as you see here. So this is the function, and this is the argument you have when this is if the function returns something or not. This is similar to what you used to do in C language. Okay, this is so just for now, it's just a definition. Now I defined the function. So now I wanna write the content of the function. This should be done in main.asm, as you see here. So for example, if you go main.asm, you will see delay YMA, you will see all the function I'm gonna teach is already there, and they are written in assembly. Okay, guys. And then after that, you can just use it. So once you use it in C language, it's gonna be accepted. Okay, guys. Let me tell you the conclusion to make it everything easy for you. Number 1, if you wanna run a C program, you should not create a new project, right? Just use the project provided with you here, because this project has a bunch of functions. These functions are written in assembly, okay? You can just use them. Number 2, in this course, I'm not gonna ask you to write a function in C, in assembly, and call it in C. Just I'm gonna ask you to write a program in C and just use the functions I'm gonna teach. That's it. Is that okay? However, if you wanna learn more, you can just, I already give you the tutorial here. You can go and see how these functions are written. You will find this very simple. You will find, for example, here, as I told you here. So for example, if you open, for example, segment 7 disable, what you will see here in this one, you will find this one here and this one. So you'll find these 2 instructions are here. If you wanna open this one, you will find these 3 instructions are here, and so on. Okay, guys, any questions? So you have this tutorial on the course website. Any questions? Okay, now I'm gonna move to another program. In this program here, also we need it in the coming lab. It's very easy program. Very interesting, very easy. So I'm gonna teach the assembly first, and then I'm gonna teach the C language. Here in this program, I call it serial communication or serial data. So this program can be used for serial communication. You know what I mean by serial communication? Serial communication means you have only one pin. You have only one pin. You know, your data is just a bunch of ones and zeros, right? So only one pin, and you are going to send all the data serial. Serial, as you see here, this is information. So here the pin is 0 for some time. So give you 0. After some time, I'm going to give you 1. Then give you 0, give you 0, give you 1, 1, 1. Serial communication. Is that okay? Only one pin. I'm going to send the data serial. So we want to do something like that. I want to write a program. So that I'm going to display 0, 1, 0, 0, 1, 1, 1, and so on. Is that okay? How can we do that? I'm going to tell you how we can do that. Just very easy. Look here, guys. The idea, if you have a byte, okay. So for example, I want to display this one first. So this bit, for example, I want to display this bit first. All what I'm going to do, very simple. Number 1, I have to check if this bit is 1 or 0. It's very easy, right? branch if clear, branch if set. You can check if this bit is 1 or 0. If this bit, if here I want to use PT0. PT0 means port T, pin number 0, right? So after I check this bit, if this bit is 0, so PT0, I am gonna write 0 in PT0, okay? If this bit is set, I'm gonna write 1 in PT0, which is very easy, okay? You will see it right now how I made it. However, because I want you to see on the scope. So it's very simple. So I'm gonna check if this one is 0, I'm gonna write here 0. Is it difficult to write in PT0? You write 0? No, this is similar to what I did here when I wrote at PP0 here, but instead of port P, I'm gonna use port T. That's it. That's the only difference. It's the same thing. Bit set, bit clear. That's it. Okay. But because I want you to see this one on the scope, so if you display this one time, it's going to be too quick. You're not going to be able to see it. So that's why I'm asking you. I want to repeat. So that means after you display this one, you repeat it again, and then you repeat it again. You repeat it again. Again, I'm not repeating it because in reality I may need something like that. I don't think so. But I'm repeating it just to be able to see it on the scope. Otherwise, we're not going to be able to see it. That's why if you connect the board to the scope, you will see it right now. For example, if I start from here. So if I start, for example, from here, guys, you can see this is 0, 1, right? 0, 0, 1, 1, 1, 1, I guess, right? Is that the same number? 0, 1, 0, 0, 4 ones, yes. And then you can see it is repeated. So this is one thing here, and then you can see it is repeated again. Repeat it over and over again so that you can see it. Is that okay? That's what you are going to do. By the way, the coming lab needs a scope. The coming lab needs a scope. We can bring some scopes. However, I know you should have discovery kit. Can you bring your discovery kit to use it as a scope, or you don't have it? Anybody here? You don't have discovery kit? Okay. Anyway, I'm posting. Don't worry. I'm posting. I posted two labs, 2 versions of the coming lab. One version in the coming lab. By the way, number 1, the coming lab is too easy. I made too easy intentionally because this is the first lab. We are going to use the board. I know we may face some trouble to do that. This is the first lab. You have to include subroutine as in cell assembly. This is the first lab you have to use the project on the course website. That's why I made it easy so that I know we're expecting all these problems. So in the coming lab, it has 2 parts. The first part is just a little modification to this program, this flashing LED, right? You know, as I told you here, guys, in flashing LED, I actually created a square wave. That's it. So in the coming lab, I'm going to ask you to create a square wave in different ways. So here, I can tell you, like, you do something like that. You can do something like that. Very easy. You just output 1, output 0, wait some time. Very easy to generate something like that. So I posted 2 versions of this lab. They are the same. The only difference is one version, this time is very small time, so that you can see it on the scope. If you have access to a discovery kit, or you can use one of the scopes we can bring. The other lab here, I just make the time big, for example, in seconds, so that you can observe it by your eyes, because you can see the LED is going to be on for 4 seconds and then off for 1 second. Is that okay? But I wish if you can see it on the scope, because in the future you may need to see. So all what you have to do, guys, the scope should have two wires, 1 wire for ground. So you can have to connect it here. If you see here, there are several grounds here. So you can connect it to any ground. The other one here, you can connect it to the pin. So for example, pin PB0, okay? But for sure, these pins are very tiny. These pins here are very tiny. You cannot connect it here. That's why all these pins are connected outside here. You see what I'm saying? So let me here. Yeah. So here, guys, all the pins are here. because this is the chip is here, the pins are very tiny here. Okay, so they are written here. So PB, as you see here, guys, can you see it? PH7, whatever. So you can connect this terminal to the scope. The second one, you need ground. You find a lot of ground. So this one is a ground. You can find another ground here. Okay, you can find the grounds everywhere. So I'm sure if everywhere you can find the ground, any ground should be okay. Okay, anyway. So if you have the discovery kit, this would be great. Just to bring it. We will try to bring some scopes in case if there is no way to do it this way. So you can simply make the other labs that just increase the time so that you can see it using your eyes. So this is. So now let's come to this program, the serial communication one. Yeah, here. Okay. So now, so I want to repeat. Okay, guys. So the way, look how I'm gonna make it. Look here, guys. You have a byte. This byte has the information here in this byte. Is that okay? So number one, I'm gonna shift. If I wanna display from here to here, so I'm gonna shift right so that I get this guy first. If you want to display from here to here, so you have to shift left so that I get this one first. So the idea, whatever it is, it doesn't matter what direction it is. For example, so here I'm going to shift first. Once I shift, this bit has to go to the carry, as you know, and then I'm going to check the carry. If the carry is 1, so I'm going to output 1 here. If the carry is 0, so I'm going to output 0 here. Very simple, right? Is that everything? No. The value here, because you know when I shift, I'm going to insert 0. This value, I have to write it back here. Why you have to write it back? Because after 8 iteration, I have to get the same number again so that I repeat, to be able to repeat. You get what I'm saying? So very simple. So the idea I'm going to show it right now, number 1, shift. Number 2, it checks the carry. If the carry is 1, write 1 here. If the carry is 0, write 0 here. Okay? Number 3, you have to copy the value of the carry here. If it's 0, you put 0. If 1, put 1. Actually, if it's 0, you don't need to do anything if it's 0, because shift is going to put 0. But anyway, in case. So let's see how I make the program here. Look here, guys. So here I define a variable memory location. I'm going to call it P, as you see here. And then I'm going to copy. This is the same number here. You can easily change this number. You can put any other number easily, right? So I'm going to copy this number. I'm going to put it here. That's totally fine. And then because I'm using PT0, as I said before, I shouldn't repeat it again. It's like rule of thumb, okay? Before using any port, you have to configure it input or output one time. That's it, okay? That's what I did. So what I did here, guys, here, because PT0, I'm going to use it output. So in DDRT, I have to put 1 here, right? Just because 1 means output. This is the way I did it using move, but you can do it using OR operation, as I explained before. So this is initialization only one time. All the time will be here. This is infinite loop. So all the time, most of the time, the program will be here all the time, looping all the time. Okay. So now, okay. So as you see here, guys, number 1. So number 1, I'm gonna shift B. Okay, shift left or right. But here in this case, I shift it left. So I wanna display from here. So I'm gonna shift left. So number 1, I'm gonna shift B. Okay, as I mentioned. Number 2, I'm gonna check the carry. If the carry is high, is the carry is set, so go to high. Is that right? What should I do now? I have to do 2 things. Number 1, PT0, I have to put 1, and that's what I did here. Using bit set BTT, right? 0, 1. This number 1. Okay, I'm gonna output 1. Number 2, I'm gonna put the 1 back here, not here, because I started from here. So I'm gonna put it back here. Okay, so that's what I said using bit set. Is that okay? So I have to do 2 things. If it is not high, that means the carry is equal to 0. What should you do? Same thing, but I'm gonna write here 0 here. And actually, I don't need to do anything here. Or if you want to do something, just put 0. You don't need, because shift is going to put 0. But anyway, I put here 0. So as you see here, guys, now if the carry is 0, so number 1, I'm gonna PT0 here, PT0 is equal to 0. Number 2, P, I'm gonna put 0 here, as you see here, okay? And then I'm gonna skip this one to come to here, okay? And then you should put here some delay. I didn't put delay, but you should put some delay here because there should be some delay. So I have to keep the 0 for some time. I have to keep the 1 for some time. I have to keep the zeros for some time, right? Because in serial communication, I have to make sure I have to keep the 0 until the receiver is gonna take this value. If I just keep sending data very quickly and you're not able to absorb this data with the same speed, we're gonna lose synchronization, right? So that's why I have, here you have to put some delay here, 5 millisecond, 10 millisecond, whatever, because I wanna keep this 0 for some time. Is that okay, guys? Any questions? Anyway, this is the second part of the lab. In the second part of the lab, you will do the same thing here, just you will see it on the scope, that's it, okay? Very easy lab. How can we do the same thing in C language? Okay, exactly same thing. However, I'm gonna use I'm gonna use a little bit different idea here. Don't tell me why use the different idea. I can use the same idea, but just again, it's good for programming. To learn programming, it's good just to learn different ideas. Okay, it's not very far, but I'm gonna tell you the idea I'm gonna do here. What I did in the other one, I had P. And now I shifted P this way, so this one has to go to the carry. That's what I did. Here in C language, I'm gonna twist the idea a little bit. So I'm not gonna shift P, I'm gonna keep P. So this is P, and then I'm gonna use something, I'm gonna call it mask. Okay, so this mask should have 1 here and 0, 0, 0, 0, 0. Okay, because I wanna check this bit using AND operation. We don't have branch if clear. Remember, we don't have here in C language, we don't have branch if clear, we don't have branch if set. So we don't have branch if clear or branch if set. How can you do that? Similar to what I taught in chapter 2, you can use AND operation to check some bits. That's exactly what I'm gonna do right now. So I'm gonna have a mask this way, okay? The 1 is here because I wanna check this bit. Then I'm gonna do AND operation. Now, if the result is 0, 0, 0, 0, that means the bits I'm checking is 0. So this bit is 0 if the result is 0. Otherwise, it is 1, right? Again, nothing is new. This is what I taught in chapter 2. How can you use logic AND to check some bits? We're going to do it here. Okay, so this is in one iteration. In next iteration, I'm going to shift mask so that the 1 will be here. Why? Because this, the second iteration, I have to work on this bit. In third iteration, the 1 is here. So if you look at mask, it has only 1 bit is 1 at a time, and all the bits are zeros. So I start with 1 is here because I want to check this bit. Next iteration, 1 is here because I want to check this bit. And then the 1 is here, 1 is 0, 1 is 0. Once I finish shifting, I have to return this one to the beginning again. Okay, to repeat. That's you will see right now. So let's see how I made it. Number 1, guys, similar to what I did in C. Number 1, because I'm using PT0, so you have to program PT0 as output, as you see here. Okay, data direction register T. Okay, this way. This is number 1. Number 2, this is the pattern. The pattern is here. This is a variable called P I used before. It's the same thing, but I just use a different name. This is a pattern I want to generate. Okay. Also, I told you I'm going to use something called mask. So I'm not going to shift the pattern. I'm going to shift mask. Every time I'm going to shift mask. Someone can tell me, so why you didn't shift the pattern? You can do that. You can shift the pattern as we did before. Okay, but just I want to use a different idea. Okay, I want you to learn a different idea. So here, I'm not going to shift the pattern, but I'm going to shift this mask. So if you look at the mask here, guys, I put here 1. It's going to be 1, 0, 0, 0, 0, 0, 0, 0. Okay. And then in second iteration, the 1 is here. Next iteration, the 1 is here. So I'm going to shift it every time. So this one is shifted, as you will see here. So now this is just initialization 1 time. And the program is here. This is infinite looping. So you will see right now here, guys, what I did here. I'm gonna, as I told you, I'm gonna do logic AND between mask and pattern, as I told you. So now the mask is 1, 0, 0, 0, and this is pattern. So I'm gonna do AND, logic AND, and then I'm gonna look at the result. I'm gonna see if the result is equal to 0 or not. So look how I made it. As you see here, guys. Yeah, so this is pattern and this is mask. I do AND operation and then I compare it to 0. If the result is 0, that means the bit you are checking, the bit I'm interested in, this bit is 0. Okay, so as you see here, guys, because the bit is 0, so I'm gonna output 0, as you see. Otherwise, I'm gonna output 1. So this is the body. This is the body of F here. This is F statement. So if the result is 0, that means the bit is 0. So I have to output 0. Otherwise, I have to output 1, as you see here. Okay. So now what should I do after that? You have to wait some time, as I told you, because if you output 0 or you output 1, you have to keep it for some time. So here I decided to wait 10 milliseconds. You can wait 5, whatever you want. Okay. So now after that, what should I do? What I have to do, I have to shift mask, because if the 1 is here, I have to shift it so that I have to shift it this way. So that next time the 1 will be here and I have to check the next bit. Yes, that's what I did. So I'm going to shift the mask to the right 1 time. Is that okay? What else? Now, if you shifted it all the way and now it is 0, 0, 0, 0. After 8 iterations, in the beginning, if the beginning 1 is here, look here, guys, this is mask. Okay. In next iteration, the 1 is here. Next iteration, the 1 is here. After 8 iterations, should be 0, 0, 0, 0. Is that okay? Because I have to repeat, because I want to repeat. So after 8 iterations, I have to bring the 1 back to here. And that's what I did here. I'm going to say, if mask is equal to 0, so reinitialize it again to 80, because I want to repeat. Okay? And I told you why I want to repeat, as I have just mentioned. I want to repeat because I want to see it on the scope. If you do it only 1 time, it's going to be too quick. You're not going to see it. Okay? Any questions? Great. Very, very important thing. Listen to me. You did something weird here. I know it's really, I'm going to explain it, but in my opinion, it's very weird for C language to do it this way. I'm going to tell you why. Look here. Even honestly, in the beginning, when I taught this course, I myself got confused. It's somewhat weird from C language. I'm gonna tell you what is. Why you put parentheses here? Can I delete them? Make it this way? Why you put parentheses here? The answer is no. It's gonna make mistake. I did it by myself. It happened to me. You know why? Something very weird in C language. I'm gonna tell you why. You know, in C language we have priority, right? So for example, multiplication, like multiplication should be done first. Anything inside parentheses should be done first, right? So there are some priority. Is that okay? For some reason, so what you want to do here? What I want to do, guys, I want to do this operation first. That's what I'm expecting, right? So I want to do this operation first, and then I'm gonna get a result here, and then I'm gonna compare this result to 0. So this operation should be first, this operation should be second. That's what I want to do, right? However, the way they meet C lang, if it is summation, you are okay. If it is multiplication, totally fine, you are okay, right? However, I don't know why, the way they did C language, they give more priority to it, to this one than this one. You okay? So what's gonna happen if you forget the parentheses here, if you forget them here, what's gonna happen? C language is gonna do this part first. It's gonna do this part, and this operation, by the way, by itself, as I explained before, if it is equal, this is operation, and the result of this operation should be 0 or 1. 0 if it is false, 1 if it is true. So if it is true, it's gonna give you 0, and then it give you 1. And then number 2 is gonna do the AND, this one with this one AND. Okay, and then whatever inside F, if it is 0, that means it is false. Otherwise, it takes it like a true. Anyway, for sure, that's not what I want to do. So conclusion, guys, you should understand that this equal has more priority than this one. So you have to use here parentheses in order to force the C language to finish this one first, and then compare it to this one. Again, if it is addition multiplication, you don't need to put here parentheses because it has higher priority than this equal. Any questions? Okay. So we are gonna have a lot of fun, I'm sure. So now I want to move to another program just in this 1 minute missing. I wanna explain this one. We have a buzzer here. You can see this buzzer. We have a buzzer here. This buzzer can make some sound. Okay. So in this program, I want to make the police alarm siren or police siren, whatever you want to call it, alarm siren. In the alarm siren, you have so one tone, second tone. So the way I'm gonna do it, I have to generate two tones, two different tones. I have to keep every tone for a certain time, and then I have to alternate. This is the main idea. You get what I'm saying? So number one, this buzzer is connected to PT5. It's connected only to one pin, PT5, port T pin number 5. Is that okay? So it's connected to PT5. This is number one. Number two, how can you make a tune? How can you make this tune? Very simple. All what you have to do is just generate a square wave here. It's too easy. We already generated the square wave. The flashing we did was a square wave, right? So just generate a square wave here. And by changing the frequency of this square wave, you can change the tone. That is, if you want to make the police siren, so I should have two different tones. That means two different frequencies. That's exactly what we're going to do. So what we're going to do here, I'm gonna select 250 hertz and 500 hertz. One is going to make the other one because it's two different tones. Is that okay? Okay, that's great. I'm going to teach it next time. Thanks, guys. This lecture should end 15, right?